My name is Tom, and in this video I will show you how to answer some fundamental questions regarding vectors. So the first step is be sure you can construct an x and y coordinate system so that you know how to draw points within this system. Say you are given the following. This is a common exercise in many calculus books. A little later in the calculus sequence, you might be given a point with coordinates 1, 2, and it leads to the point with coordinates 5 and 5 as follows. So the first step is draw an xy coordinate system. So draw your vertical axis, draw your horizontal axis, mark in convenient units. So here, so that it's easy to see, I will take two every spaces on the paper as 1. So 1, 2, 3, 4, 5, 6. Likewise here, 1, 2, 3, 4, 5, 6. First, let's mark the points in the plane. So you've got 1, 2 as the first point. I like to color code sometimes, it's very helpful. So here we are. This is 1 point, 1, 2. Let's write in the coordinates. Here we are. Let's mark the second point. So that ends at 5, 5. So 5 to the right and then 5 straight up. So 5 to the right and 5 straight up. Where is that? There we are. Okay, so label it 5, 5. Once this is done, connect these 2 points with an arrow representing the vector. A vector is a directed line segment. So it's not just a chunk of a line, it's got to have the appearance of an arrow, okay, like this. Not just a segment, but it's a directed line segment, so it's an arrow. So it looks like this. Okay? And the first step, or the first question, might be the following. So sketch the directed line segment, done. Okay? Second step, write it in component form. So what this means is the following. Give the vectors some names, such as v, doesn't really matter. Okay, so the vector v here is equal to the following. And to write in component form means take the difference of the x's between the 2 points and the difference of the y's between the 2 points. So before we can do that meaningfully and correctly, let me mark this, okay? And you'll see in a second why. And now take a look. The segment I am about to draw is the x component of the vector. This one right here. Okay, there you go. That's the x component of the vector because it lies parallel to the x-axis. The second segment looks like this. Green. This is what's known as the y component of the vector because it lies parallel to the y-axis. And now these are the pictures of the vector and its horizontal and vertical component. Now let's take a look at getting this to be a numerical quantity. So the way to do it is as follows. To find this, if you're using grid paper, of course, you can just count the boxes, right? But if not, then you've got to have an algebraic way. So that is the following. 5 minus 1. And for the vertical component, what you will do is write the 5 minus 2. And the rest of it is simplification. So what you have is 5 minus 1, which is 4. That's the horizontal component. And then 5 minus 2 is 3. So that's the vertical component of the vector. Okay? There we are. So what this is saying is this. This 3 that I've drawn here represents the fact that this that I'm showing with my fingers is 3 long. Okay? So 1, 2, 3. Okay? Remember here, every 2 boxes correspond to the number 1. so it's easier to visualize on camera. All right, and then take a look in the bottom. There's your 1, 2, 3, 4, right? So that's 1, 2, 3, 4. So this one is 4 long, that one is 3 long. This is the vertical component, this is the horizontal component. The way to find these is you do 5 minus 1 for the horizontal, you do 5 minus 2 for the vertical, and then you write down this. This is the component form of the vector. And you may also be asked to sketch a picture of the vector from the origin. So once again, what you will have to know how to do is draw an XY coordinate system, label everything clearly as always. That's a really good habit. Mark your axes on a convenient scale. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then take your vector here and draw it from the origin using the components. Okay, so I know that may not be the most meaningful statement the first time you hear it. So what we mean once again is from the origin, first draw the 4. Okay? So let me grab a different color here. Okay, because that was red. So from the origin, draw the horizontal component of 4. Okay, so draw an arrow that is of length 4 along the x-axis, as I've done here. Once you've done this, you turn and you draw the vertical component of the vector, so that's 3. Right. 1, 2, 3. Okay, so there's the vertical component of the vector. It's just that arrow. And lastly, as before, you connect the origin and the end of the black arrow. So it looks like this. Okay, so we have taken the original vector from this picture. We have found it and expressed it in component form. And then we've drawn a new picture with the vector translated or moved in such a way that it now initiates at the origin as shown in the picture here. Okay? So this is the kind of a common exercise that you will have to do in calculus, usually in calculus 3 or towards the end of calculus 2, but also in trigonometry and other places. So thank you for watching and have an absolutely amazing day.